Okay, this is lesson 9.1.4 titled Can Angles Show Similarity? So we're going to be talking about the AA triangle similarity today. So we are going to go back to dilations first in this lesson. So remember in chapter 6 we learned we can create similar figures by using dilations, which was making a shape bigger or smaller. Today you'll investigate what happens to the angles in a figure when you enlarge or reduce the figure to create a similar figure. So it says to use a sheet of graph paper and a straight edge, but I know a lot of us don't have it, so you might want to draw your own coordinate graph right now. And let me see if you need to draw two. I would just draw one for now for part A. And you're going to be graphing this quadrilateral, and I'll show you what it looks like in a second. But it starts with 0, 3, 4, 0, 2, -2, and then -2, 1, and it will make a rectangle. And I'll show you in just a second, but it says for part B to enlarge the quadrilateral by a scale factor of 2. So this is how I did it on my paper. I took all the coordinates and I just multiplied each coordinate by 2 to make the enlarged shape. So there's my new coordinates, and I'll show you my lovely graph. So here was my original figure, and then here is my enlarged by 2. It's double its size now. So that's what it looks like. I know this line looks curved. It should be more straight than that, but I didn't have a ruler, so that was what mine looks like. So it says for part C, what do you notice about side MN? So our original MN side and our new one. So that little apostrophe next to that M just means it's like the new M side. So M and N here. And I just put that it's twice as large. This side is twice as large as this side. And I also said that they are also parallel. So this side and this side are parallel sides. Okay, so then that was part C. Part D says, what can you say about angle M and angle M apostrophe? I'm just going to start calling that M1. So M and M1. And it looks like, to me, they are the same angle. So they are equal angles. So it says for part E, remember that a conjecture is an inference or judgment based on incomplete evidence. Based on your work in this problem so far, make a conjecture about the angles in similar figures. So I said that the corresponding angles, so corresponding just means if you have two shapes, it's the angles that would match each other. So this is a corresponding angle to that one, and that's a corresponding angle to that one. So this would be corresponding to that one corresponds to that corresponds to that one, okay? So I put that corresponding angles in similar figures are of equal measure, okay? Because we figured that the M and the M1 are equal angles. So now for part F, it says to test your conjecture in part E using a figure of your own design and different scale factors. So you're gonna have to draw your own. So you're gonna make another coordinate grid, but you're gonna make your own figure, and I'll show you what I did. Here's what I did. So that was my original figure, just the very simple square, and then I timesed it by 3 this time because it says to use a different scale factor. So here's my original coordinates that I have for A, B, C, and D, and then I multiplied each one by 3 to scale it times 3. So this square is 3 times as big as this square. Okay, and all my coordinates match up. All right, so 9-40 says, imagine that 2 pairs of corresponding angles in 2 triangles are of equal measure. What could you then conclude about the third set of angles? So here's what I did. I drew 2 triangles, and I drew this angle and this angle as being equal to each other, and this angle being equal to each other. So I said, well, if we don't know that third angle, say this was a much bigger triangle than this one, but the angles were still the same, the third angle must also be of equal measure to each other. So that angle and that angle would be equal to each other. Say that was a lot bigger though. I should have made, they look way too similar right there, but I should have made it a little bit more different. That's okay. Okay, for 941, use your conjecture from part E of 939 along with your work from 940 to explain how you can use the angles in a pair of triangles to determine if they're similar. Be sure to include how many angles you need and what needs to be true about them. So I wrote a conjecture about this, and I said if two pairs of corresponding angles are of equal measure, then the triangles are similar. And you can write that down. If two pairs of corresponding angles are of equal measure, the triangles are similar. Because you'll notice I have a pair here that's equal and a pair here that's equal. So that means that those are similar triangles. All right, moving on to 942. So it says we're going to be introduced to this new term. It says the relationship in the previous problem is called angle-angle similarity, and it is written with a double A, the little squiggly line. The symbol, the squiggly line, means similarity or is similar to. In the figure at the right, is triangle ABC similar to triangle EDC? So let's look at triangle ABC and EDC. So we want to see if they're going to be similar. So I'm looking at them and I'm thinking, well, they both have a 90-degree angle, so that's one pair of corresponding angles that are equal. So let's see, is there another pair that is corresponding that we know have to be equal? Well, I see a vertical angle here and a vertical angle here. So vertical angles are those angles that are like opposite of each other, and those will always be equal to each other. So yes, there are two pairs of angles in these triangles, two pairs of corresponding angles that are equal to each other. So angle, I put, it shares two pairs of corresponding angles that are equal. Angle B is equal to angle D, and angle C is equal to angle C, obviously. All right, let's see, 943. I think that's the last problem. It is. It's gonna be a short one. Eleanor and John were working on a geometry problem together. They knew that in the figure below, line M is parallel to BC. They wanted to find the side lengths of each triangle. First, they decided they needed to show that triangle AED is similar to triangle ABC. Eleanor said, that's easy, we have parallel lines. So the triangles are similar by angle-angle similarity. Hold on a minute, John replied, which angles are equal? So first, let's see. A, using the diagram at right, name the pairs of equal angles Eleanor sees. Why are they equal? So she says we have parallel lines. Okay, so let's see. So this big triangle is what they're comparing to this little triangle. And I think they drew it down here, but I think we're not at that part yet. So here's this little one, and here's the big triangle. So I'm gonna say that she sees this angle right here, angle 1, and I think she's saying that it's similar or it's equal because of this angle right here, this angle B. And then this angle 2 must be equal to that one because they are cut by a transversal. Say those were parallel lines going forever, and they're cut by that transversal. So that means this angle would be equal to that angle. So those are the two angles she sees, two pairs. Are the triangles AED and ABC similar? And I'm saying yes, because we know that this angle and this angle are equal, and this angle and this angle are equal. So two pairs of corresponding sides are equal. So that means they are similar. So now part C says, now that John sees how the triangles are similar, he suggests redrawing them separately as shown to the right. Look, he says, now we just write a proportion. He suggests the following equation. So here's his little drawing. So he has measurements now. So here's the little triangle that he cut out and put right here, and here's the big triangle that's being compared to. And then he's noticing he puts that 3 over 3 plus 5, and then he puts that x over x plus 8, because we're going to solve for x. So if you have this proportion, I'm going to show you the the shortcut way to solve it, which you probably already know, which is the cross multiplying. I'm gonna try my hardest to do it so that you can see it on my paper. Okay, so 3 over 3 plus 5 equals x over x plus 8. All right, so if I cross multiply, I want to multiply those two things together, and I want to multiply those two things together. So you'll see it made a lovely x. So let's start with this one. So x times 3 plus 5. So x times 3 plus 5. Got to put the parentheses because we're distributing. And then 3 times x plus 8. All right, so now we are going to distribute. So let's distribute this x to the 3, the x to the 5. If you want, you can just really add 3 plus 5, which gives you 8, because we're going to get the same thing. 3x plus 5x equals, and let's distribute this 3 to everything inside, 3x plus 24. Let's combine like terms on this side. We're left with 8x equals 3x plus 24. I want this x away. I want him on this side, so I'm going to subtract 3x because I want him to be 0. Subtract the 3x from that side. I'm left with 5x equals, bring down the 24. You will need a calculator for this one. Divide by 5, divide by 5, and plug that into your calculator. 24 divided by 5, 4.8. Okay. It was kind of a lot, but knowing about angle-angle similarity is important, and we're going to get into the very new but very important triangle theory next week called the Pythagorean theorem. Lots of shapes going on. See you later.